We will now discuss the solution of a problem from the section Differential Equations. The problem is on a homogeneous linear system of differential equations. It is a system of differential equations which is linear and homogeneous. Homogeneous linear system of differential equation. And this problem has appeared in CSIR National Eligibility Test held on 26th November 2020 and it is from the section C. The problem is consider the solutions. y1 is a column vector e power minus 3t, e power minus 3t, 0 and y2 another column vector 0, e power minus 5t, e power minus 5t to the homogeneous linear system of the differential equation and which is denoted by star. Y prime t is equal to the 3 by 3 matrix whose first row is minus 5, 2, minus 2, second row 1, minus 4, minus 1, third row minus 1, 1, minus 6 multiplied by the column vector yt. Which of the following statements are true? Options. 4 options are given to us. Option 1. y1, y2 form a basis for the set of all solutions to the star. Option 2. y1 and y2 are linearly independent but do not form a basis for the set of all solutions to the star. Option 3. There exists another solution y3 such that y1, y2, y3 form a basis for the set of all solutions to star. Option 4. y1 and y2 are linearly dependent. Let's now discuss the solution of the problem. Given the homogeneous system of first order linear differential equation and this is a homogeneous system and it is y prime t is written as a times y of t where a is this 3 by 3 matrix. If lambda is an eigenvalue of this matrix A and x is the corresponding eigenvector, then z is equal to e power lambda t x is a solution of this system denoted by star. Now, let S be the set of all solutions to the star. Then it forms a vector space called the solution space of star. So S, the set of all solutions of star, forms a vector space called the solution space of star. Any 3 linearly independent solutions of S is a basis of S. Now, we are given 2 solutions for the system given by star. And what are they? y1 is equal to e power minus 3t, e power minus 3t, 0, the column vector, and y2, the column vector, 0, e power minus 5t, e power minus 5t are the solutions to star. That is, y1 is equal to e power minus 3t multiplied by the column vector 1, 1, 0. Denote this 1, 1, 0 by u and lambda by minus 3. That is equal to e power lambda 1t u. And y2 is equal to e power minus 5t 0, 1, 1. That is equal to e power lambda 2t v. and where lambda 1 is minus 3, lambda 2 is minus 5 are the eigenvalues of this matrix A with the corresponding eigenvectors u is equal to 1, 1, 0 and v is equal to 0, 1, 1. Let's now discuss the statement given in option 4. Option 4 says y1 and y2 are linearly dependent. Now, u is equal to 1, 1, 0 and v is equal to 0, 1, 1 are linearly independent. Why? Because they are the eigenvectors corresponding to distinct eigenvalues of A. Therefore, they are linearly independent. And the theorem is the eigenvectors corresponding to distinct eigenvalues of a matrix are linearly independent. So, these are linearly independent. Therefore, y1 is equal to e power minus 3tu and y2 is equal to e power minus 5tv are also linearly independent. This implies y1 and y2 are not linearly dependent. Therefore, the option 4 is not true. Now we continue. We will find out the third eigenvalue. Let lambda 3 be the third eigenvalue of this matrix. And now lambda 1 plus lambda 2 plus lambda 3, the sum of the eigenvalues is equal to trace of the matrix A. And the trace of the matrix A is the sum of the diagonal entries of the matrix A. That is equal to minus 5 plus minus 4 plus minus 6, that is minus 15. And lambda 1 is minus 3, lambda 2 is minus 5 and lambda 3 will be minus 7. Let W is equal to the column vector A, B, C be the eigenvector corresponding to the eigenvalue lambda 3 is equal to minus 7 and it is given by A minus lambda 3i multiplied by W is equal to 0 and lambda 3 is minus 7, that will be A plus 7i multiplied by W is equal to 0. And A is here, A plus 7i we will write, and this is your A plus 7i, that is the diagonal entries are added by 7 and multiplied by W, that is ABC, the 0 column vector 0, 0, 0. So that is simplify and this matrix will become 2, 2, minus 2, 1, 3, minus 1 and minus 1, 1, 1 multiplied by the column vector ABC is equal to the column vector 0, 0, 0. We will now solve this system of equations, homogeneous system for ABC. To do that one, we will reduce that matrix into a row reduced echelon form. So we will reduce this matrix to a RREF, meaning the row reduced echelon form. So take the matrix, right, we have, and divide the entries of the first row by 2, that is R1 is half R1. So the matrix will become this, first row will become 1, 1, minus 1, the rest of the entries will be same. Now we will make this entry 0 and this entry 0. To make this entry to be 0, we will subtract the entries of the first row from the second row. To make this 0, we will add the entries of first row to the third row. And then this will become, the second row will become 0 to 0, the third row 0 to 0. What we do is divide all the entries of the second row by 2. That is, R2 is 1 by 2 R2. Thereby you will achieve 0, 1, 0 here. Then you make this is 0. And that will be R3 is R3 minus 2 times R2 after making this as 1. So you will get this one. 1, 1 minus 1, 0, 1, 0, 0, 0, 0. This is the row reduced echelon form. This is the echelon we have. Right? So now by back substitution, we will find out the values of A, B, C. So this is the matrix. The row reduced echelon form multiplied by the column vector A, B, C is equal to the column vector 0, 0, 0. And by back substitution, B is equal to 0 and C is equal to A. So you will get A plus B minus C is equal to 0, and B is 0, A is equal to C, that is C is equal to A, where A is arbitrary. Why? Because the rank of this is 2. So where A is arbitrary, so the ABC is equal to A0, A is an eigenvector corresponding to the eigenvalue lambda 3, and therefore W is equal to 1, 0, 1 is an eigenvector corresponding to the eigenvalue lambda 3 is equal to minus 7. Therefore, Y3 is equal to e power lambda 3t into W is equal to the column vector e to the power of minus 70, 0, e power minus 70 is a solution of star. Thus, we have found yet another solution for the given system given by star. So we now claim that the given y1, y2, now we have found y3. The set B is equal to y1, y2, y3 is a basis for the solution space. How do we show that? So first of all, what are y1, y2, y3? y1 is equal to e to the power of lambda 1 tu, y2 is equal to e to the power of lambda 2 tv, y3 is equal to e to the power of lambda 3 tw are the solutions of star. Lambda 1, lambda 2, lambda 3, they are distinct. And now what are UVW? UVW are the eigenvalues corresponding to the distinct eigenvalue. UVW are the eigenvectors corresponding to the distinct eigenvalues lambda 1, lambda 2, lambda 3. Therefore, they are linearly independent. UVW are linearly independent since they are the eigenvectors corresponding to the distinct eigenvalues. And we are using the theorem, the eigenvectors corresponding to distinct eigenvalues of a matrix, a square matrix, are linearly independent. Therefore, y1, y2, y3 are linearly independent, and any three linearly independent solutions of a space of S will form a basis for S. Therefore, B is equal to y1, y2, y3 is a basis for S. Thus, there exists another solution y3 such that y1, y2, y3 form a basis for S. Let's look at the options. And in these options, option 3 says there exists another solution y3 such that the set y1, y2, y3 form a basis for the set of all solutions to star. That is, it forms a basis for S. So, the option 3 is true. Further, y1 and y2 do not form a basis for S. Why? We need three solutions to form a basis. These two cannot form a basis for S. So, the option 1 is not true. y1, y2 form a basis for the set of all solutions to star is not true. And we have already seen y1 and y2 are linearly independent, but they do not form a basis because we need 3 vectors for that. So it says option 2 says y1, y2 are linearly independent but do not form a basis for the set of all solutions to star. So therefore the option 2 is true. So option 4 is not true. 2 and 3 are true. Option 1 is not true. Our final answer is options 2 and 3 are true. That is the discussion of the solution of the given homogeneous linear system of differential equations. And it is a very interesting problem, and work out some more problems on these lines from the system of differential equations. And I am sure that you have understood the solution and liked the problem. I wish you all the best. Thank you.